Today in class we worked on what do you expect 1.4 and 2.1. We talked both about why certain events are equally likely to happen or not equally likely, and we also talked about how to calculate theoretical probabilities. We're starting to think about how do theoretical probabilities compare to experimental probabilities. So we hope you've had a chance to complete page 11, and now you can correct them with this section. Decide whether the possible results are equally likely. Your phone rings at 9 p.m., the caller is your best friend, the relative, or someone else. Well, I don't know about you, but people don't generally call me at 9 p.m. at night that are totally random. So I'm going to say that this is not equally likely because I have a feeling my friend would be maybe more likely to call me later at night, or maybe a relative, but probably not a random person. You check the temperature at your home tomorrow morning. The temperature is 30 degrees Fahrenheit or above, or the temperature is below 30 degrees Fahrenheit. Well, thinking about what the temperature has been right now, if we're looking in the morning, we know here maybe the temperature is 40 degrees or something like that. Is it equally likely to be 30 or above or below 30? Well, this time of year, that's probably not equally likely because it's a little bit warmer than 30 degrees sometimes in the morning here. Again, if you want to reason this through a different way, if you want to say we're talking about the middle of winter and maybe there's a more equal chance, you can do that too. But in my situation here, I'm saying these are not equally likely. You spin the pointer once on a spinner that is 50% red, 25% blue, and 25% yellow. So just kind of to envision what this looks like. The pointer lands on yellow, red, or blue. Looking at what's here, I can see that I have a 1/2 or 1 in 2 chance of getting red, but my blue and yellow sections are much smaller. They're only about 1/4. So I'm also going to say that these are not equally likely. You find out how many car accidents occur in your city or town yesterday. There were fewer than 5 accidents, there were exactly 5 accidents, or there were more than 5 accidents. This is kind of an interesting situation to think about. Do you think all those things are equally likely to occur? Well, there's usually some car accidents that seem to happen every single day, and so it may seem kind of difficult to quantify it exactly this way. Based on the size of the city where we live and all those kinds of things, it's probably not equally likely that all of those events will happen. So we're going to say not equally likely. Again, in a lot of these situations, if you have a different way to reason through it and talk about it, you can make arguments in other ways. I'm just providing you one perspective. A bucket contains 1 green block, 1 red block, and 2 yellow blocks. You choose 1 block from the bucket. So sorry, I'm going to have to change that to 1 block. Find the theoretical probability that you will choose each color and use probability notation. So what's the probability of choosing red? Well, the probability of choosing red, we have 1 red block out of how many total? There's 1 green, 1 red, and 2 yellow. So there's 4 blocks total. Probability of choosing green. There's 1 green block, so 1 out of 4 total. And the probability of choosing yellow. There's 2 yellow blocks, 2 out of 4. I can also simplify that to 1/2. Now we're going to find the sum of the probabilities from part A. 1/4 plus 1/4 plus 2/4 or 1/2 would equal 4/4, which is the same as 1 whole. What's the probability that you will not choose a red block? So P not red equals, how many of them are not red? Well, 1 is red, and there's 4 blocks. So the ones that are not red are the other 3. So 3 out of 4. So again, you might think about knowing that there's 4 blocks in there, and you took away the 1 red block, and so you were left with 3 that were yellow and green. So we have a 3 out of 4 chance of choosing a block that's not red. What's the sum of the probability of choosing a red block and the probability of not choosing a red block? Well, my chances of choosing a red, I already found up above, is 1/4. That's up here. My chances of not choosing a red is right over here. P not red is 3/4. If I add those together, 1/4 plus 3/4, I get 4/4, or 1/2. That's the end of our homework for today. Tomorrow we're going to continue to explore more about theoretical probabilities.